Hey guys, I'm Justin Svegliato, and today I'm going to talk about our paper, Ethically Compliant Sequential Decision Making. Really, the goal of our paper is to introduce a framework that enables autonomous systems to comply with an ethical framework or an ethical theory. So let's begin with some motivation. As we all know, autonomous systems have been deployed in a wide range of applications that have a profound impact on society. It's therefore critical that these autonomous systems have the ability to comply with an ethical theory, at least some form of an ethical theory. However, despite studying ethical theories in detail in moral philosophy over the last 2,000, 3,000 years, they're still extremely hard to encode in autonomous systems. Now, a simple approach to encoding an ethical theory in an autonomous system would be to modify the objective function of the decision-making model directly. For instance, suppose we have some decision-making model, and we want to have it not only complete a task, but also implement some ethical theory. What we could do is we could try to tweak it and adjust it to align with the values of stakeholders, or try to align with the intentions of developers, or more broadly, follow an ethical theory. However, despite our best efforts, one of two problems could occur. The first problem is tweaking this decision-making model could cause unpredictable behavior because small changes to that decision-making model could cause huge changes to the behavior of the autonomous system. Secondly, and more fundamentally, there could be incommensurable unit conversions. Why? Because the decision-making model is now trying to reason jointly about not only completing the task, but also following that ethical theory, which might make it trade off one for the other and vice versa, which would be unideal to say the least. What we try to do in order to combat this problem is introduce a framework for ethically compliant autonomous systems. In this system, there's a module for task completion, which basically has to follow some task. And we represent that task as a decision-making model. The decision-making model, it has to maximize its objective function in order to produce an optimal amoral policy. However, in addition to that module, we also have an ethical compliance module, which is responsible for following some ethical framework. In our paper, we model the ethical framework as both an ethical context as well as a moral principle. The ethical context has all the contextual features that you would need to follow the ethical framework, whereas the moral principle encodes the moral rules of that ethical framework. And so now the optimization problem is a little bit different. We try to maximize the objective function of the decision-making model within that ethical context, subject to adhering to that moral principle. And the ultimate result would be an optimal moral policy instead of an optimal amoral policy. Before we formalize what an ethically compliant autonomous system looks like in math, let's first take a look at what a Markov decision process is. An MVP has 5 attributes. And it's really for reasoning in fully observable stochastic environments. The first environment is a set of states S of the world. Then we have a set of actions A that the agent can perform in the world. We have a transition function that pretty much tells us how performing an action in one state leads us to another state in terms of probability. We have a reward function that tells us what states are good and what states are bad, depending on the actions we perform. And finally, in this paper, we consider an initial start state function that tells us the probability of it starting in one of these states of the world. So a solution to an MDP is a policy pie, and it maps states to actions, what you should do in one state, and what you should do in another state for all the states that we have in the world. A policy induces a value function, which tells us the value of being in that state and then following the policy. And an optimal policy tells us the best possible action that we could perform in every possible state. So the goal of an MDP is to find the policy that maximizes the value function of the MDP. This optimization problem can be solved and represented using dynamic programming, heuristic search, and reinforcement learning. But this paper considers the primal form or the dual form of the linear program because it most easily represents ethical compliance and task completion. So now let's take a look in detail at that task completion module from before. Again, we have a task that we need to complete, and we model it using a decision-making model. In this case, we represent that decision-making model as an MDP. However, depending on the properties of the task, let's say the task has partial observability, you might want to use a partially observable MDP. If there's multiple agents, you might want to use a decentralized MDP. So really, the goal of the decision-making model is to have all of the information you would need for completing the task. So in an AV domain, you might have different road types, you might have different speed limits, perhaps you have a map that represents the city, you might have the presence of pedestrians and the presence of school zones and crosswalks, and other factors like that that are necessary for completing the task efficiently. The ethical compliance module is responsible for following the ethical framework, and we first model it using an ethical context. The ethical context has all of the features that you would need for following the ethical framework. So it'll be a tuple that has different sets, different functions, and different real valued numbers depending on what ethical framework you decide to implement. So an AV might have to know that it's tolerable to speed on a highway because, who doesn't do that? But it's probably not okay to speed near a crosswalk or in front of a school zone because that could endanger pedestrians and students. The next component is a moral principle. The moral principle, as I discussed before, maps a policy to whether or not that policy is ethically compliant. So in one sentence, it evaluates whether that policy of the decision-making model that we're deciding to look at is ethically compliant within the contextual factors or the ethical context of the ethical framework. So in an AV domain, the moral principle, if the ethical framework were utilitarianism, might maximize the overall well-being of the moral community. But let's say in Kantianism, that moral principle perhaps would try to universalize the policy to the moral community without contradiction. Now that we understand what an ethically compliant autonomous system is, we can begin to see the optimization problem. Let's start with the traditional optimization problem of just a regular decision-making model. Really what we're trying to do is find the policy that maximizes the value function. And that optimal amoral policy might be the red dot in the green region. However, in an ethically compliant autonomous system, we'll introduce an additional constraint to that linear program that represents the moral principle. And so we'll overlay these purple regions on top of the green region. And as you can see, the optimal amoral policy is still in the same location, but the optimal moral policy shows up in the bottom right. And those two policies can be very different because the regions will be different due to the moral principle. Because these moral, or rather policies, can be very different, we've created a measurement called price of morality. Price of morality just tells us the cost to our decision-making model of trying to follow an ethical framework. And so it's going to be the max norm or the infinity norm between the difference of two different measurements, the value of the optimal moral policy as well as the optimal amoral policy on the right. So that's just the price of morality. It's telling us how much cost we're going to incur for trying to be moral or ethically compliant. So now that we've gone over the basics of the optimization problem, let's take a look at the different ethical frameworks that we considered in the paper. The first one we considered was divine command theory. Divine command theory holds that an action is moral if and only if a divine entity commands or forbids that action. Virtue ethics holds that an action is moral if and only if a moral exemplar acting in character would perform that action. However, we're going to focus on prima facie duties today, which we'll discuss in a sec, because we analyzed it a little bit more extensively than the other two. And so what we'll do is we'll show you how to create the ethical context and the moral principle for prima facie duties. So what's prima facie duties? Prima facie duties holds that an action is moral if and only if that action fulfills or upholds fundamental moral duties that can contradict each other. So in the literature, starting with Ross in the 1930s, and perhaps a little bit earlier than that, he introduced a few fundamental moral duties that we should try to follow. Let's say fidelity, gratitude, and harm prevention. In this paper, however, we consider fundamental moral duties that are a little bit more specific to robotic applications, since these are a little bit general and vague. So what we do is we represent the ethical context as a tuple of three elements: a set of duties delta, which are specific to our application and not necessarily general like those other ones; a penalty function, which tells us the penalty for neglecting a particular duty in a particular state; and then a tolerance, which affords some flexibility to the autonomous system because, not all autonomous systems or people are perfect. In addition to that, the moral principle is just going to tell us whether or not the policy is ethically compliant. Right after the equality operator on the left-hand side, we have a summation that goes over all the states. It then multiplies the probability of starting in a particular state with the expected cumulative penalty that you would incur following the policy starting in that state. And it makes sure that it's less than some tolerance or threshold tau. Now, the expected cumulative policy, or rather penalty, looks like this, but I'm not going to go into detail today. But really, if you have any experience with value functions of MDPs, it resembles that quite a bit, as you'll notice. So now that we've gone over prima facie duties, let's take a look at the autonomous driving domain that we use to evaluate our approach. Really, what we try to do is have an ethically compliant autonomous vehicle complete a navigation task, and follow one of the three ethical frameworks that I said before. So for the navigation task, the autonomous vehicle had to navigate some town, really the map on the bottom of the screen, that had different city streets, county roads, and highways, which have different posted speed limits. And when the autonomous vehicle turned onto one of those streets, it could either see heavy or light foot traffic, at which point it decided whether or not to travel at a slow, normal, or fast speed with respect to the posted speed limit. And as I mentioned before, we implemented the decision-making model as an MDP, but we also could have used other decision processes as well, such as POMDPs and DEC MDPs. For the ethical framework, the autonomous vehicle had to follow divine command theory, prima facie duties, or virtue ethics. But today we're going to focus on prima facie duties since we explained it in the talk. The two duties that we're going to consider today is efficient operation, careful operation. Efficient operation is neglected when the autonomous vehicle is driving at a slow speed with light pedestrian foot traffic, because we all know how it feels to be behind a slow driver. And careful operation is neglected when driving at a fast speed on any road type, because that could be reckless, or driving at a normal or fast speed with heavy foot traffic, because that could endanger pedestrians or maybe students that are on a campus. The first quantity that we analyzed was the price of morality, as you can tell by the orange box overlaid on top of that table. The key observation here is as the tolerance increases, the price of morality decreases. Why? Because we're affording more flexibility to the agent to not follow the ethical framework. So the price of morality is going to be less. The next thing we analyzed was the policies that were generated by the different ethical frameworks. We represented the policy as the following diagram. The blue nodes represent different places encountered along the route. The gray nodes represent light or heavy pedestrian foot traffic. And the different colored lines, where the thickness represents a probability, indicates the different speeds that the autonomous vehicle traveled at. So the orange line was fast, the green line, which was dotted because the probability was 0, was normal, and the purple line was slow. And as you can see in the optimal amoral policy, the autonomous vehicle just speeds across its route because it doesn't care about ethics at all. For the optimal moral policy for prima facie duties, but you can take a look at the paper for divine command theory as well as virtue ethics. For the most part, when there is light pedestrian foot traffic, it traveled at a normal speed with 100% probability. And when there was heavy pedestrian foot traffic, it traveled at a slow speed with 100% probability. However, in that first transition, you'll notice that it speeds a little bit because, again, we've given it flexibility or tolerance to violate some of those norms or duties just a little bit. Now, one thing I wanted to mention is this speeding could have occurred anywhere. It just happened to speed there because that was actually most beneficial for completing the task in this situation. The final thing that we did was we had planning and robotics experts who had experience with MDPs, but not at all prima facie duties. We had them complete 2 tasks to modify an autonomous vehicle to have it satisfy a list of more requirements. And they did these tasks in random order. The first task involved implementing the ethical context of prima facie duties to satisfy those moral requirements, while the second task involved modifying the reward function of the MDP to satisfy or meet those moral requirements. And here's what we observed. On the x-axis, we have the relative efficiency of the optimal amoral policy and the optimal moral policy of prima facie duties in terms of a percent. On the y-axis, we had the number of violations to the moral requirements, and we only allowed 1, so it was okay to violate 1 of those moral requirements. Each dot represents a corresponding policy that was generated by one of the 2 tasks, where the red was the MDP task and the blue was the prima facie duties task. You'll see in the lower left corner, these are very conservative policies because they don't violate the moral requirements at all. So they're moral, but they end up being a little too slow. In the upper right corner, you'll see that there are aggressive policies, which means that they're faster, but they end up being immoral because they have too many violations. Our approach, however, only resides on the center line, which was all of the optimal moral policies, which optimally completes the task while optimally follows the ethical framework and only ever has 1 violation which was acceptable. This is extremely encouraging because using our approach, the experts did a much better job of implementing the moral requirements. And they had experience with modifying MDPs, but they had no experience with prima facie duties, which shows that it's just much, much easier to use our approach. Last but not least, we just wanted to say that we have an open source JavaScript library for building autonomous systems that comply with ethical theories called Morality.js. It's freely available on moralityjs.com, and it features a customizable playground that you can play with to see what happens when you adjust various things about your domain or various things about your ethical framework. And it also has an extremely easy to use code interface that developers can use to make their own autonomous systems. Thank you.